This is a simple lighter. It makes a simple flame, nothing special. And this is also a lighter, but much more powerful. It makes extremely high voltage plasma, and it's powerful enough to even melt steel. And in this video I am going to build this from scratch, so make sure you stay till the end. When it comes to make extremely high voltage, the most essential component we need is a transformer. And a flyback transformer can easily do the job. But as you can see, these flyback transformers are quite bulky, and that would ruin the compactness of this build. So I need something smaller. You see, the reason they are so bulky is because they also contain a voltage multiplier circuit inside. But the actual high voltage winding, which is right here, is actually quite small. So if we can somehow extract just this part, we can make the whole thing much more compact, and we need to be extremely careful while doing this. After trying for a while, I realized the transformer shell is extremely hard to open. So now there's no option left, we have to build our own transformer. To make that, first we need a base to wind the wires. And I'm using this plastic frame of this spool as the base, where I'll wind the high voltage wires. And this spool fits perfectly onto the ferrite core. Here I am using not one but two of these spools stacked together, and both of them can be secured with some super glue. Now we have got two separate sections for the windings. This helps reduce the chance of internal arcing, which can destroy the transformer. But this is still not enough. We need much better insulation between the windings. You see, the air gaps between the wires can become conductive at such high voltage. And a very effective way to remove these gaps is by filling them with epoxy resin. Now, usually after winding a transformer, epoxy resin is poured on top, and a vacuum chamber is used to remove all the trapped air. But even after that, some air can still remain between the windings. So today I am going to build a transformer in a different way, which will give much better insulation, as we'll see in a moment. I am using 0.08mm wire for the high voltage winding. Now the trick here is I'll be brushing epoxy resin continuously while winding the wire, and this will eliminate all the air bubbles from between the windings, giving much more effective insulation. I am using slow curing epoxy resin here, which gives me enough time for the winding before the resin starts to set. Each section here has around 5000 turns of wires, making a total of 10,000 turns. Pretty wild. After the winding, some more epoxy resin can be poured on top, securing the windings even further. Now you might see a lot of air bubbles in the resin, but that shouldn't be a problem. The actual windings are already well insulated. After curing the resin, this is looking very promising. Now two output wires can be attached, and the insulation needs to be removed before attaching them. After the soldering, some epoxy adhesive can be used to fix them in place. And it's always a good idea to sand the surface before applying the glue. While the glue is setting up, let's take a look at the primary side. Here I will wind 8 turns of wire on the both pieces of ferrite core, and some tape can be used to secure them in place. As we finish them, one wire from the both pieces can be connected together, which will act as the center loop. Now everything can be assembled together, and I will use some tape to hold the ferrite core in place. And just like that, the transformer is now complete. Now before moving ahead, check out this soldering station that I am currently using. It's called the MiniWire TSM1. I have been using it for a while now, and it's really amazing. It comes with a separate controller, and it supports up to 200 watts of power, which is crazy for the size. I am using 210 series soldering handle, but it supports 115 and 245 series as well. It can be powered via USB-C, which is really convenient. The display shows temperature in real time, and it heats up almost instantly. So if you're interested in the soldering station, check out the pinned comment for the link. Now to make this transformer work, we need a driver, and a simple ZVS driver should do the job, which can be made using fairly simple components. The MOSFET I'm using here is very cheap and common, the Z44N. Here is the circuit diagram for this driver. After connecting the transformer to the driver, it's time for a test. Look at that arc. Pretty amazing. And the interesting part is, even after generating this much voltage, there's not even a single sign of internal arcing here. So the transformer is very well insulated indeed. Now it's time for the power source. I'm using this tiny battery for this. But this single battery can only give around 4 volts of output, which is definitely not enough. So I'm using not 1 but 6 of them in 3s2p formation, which will give us 12 volts of output, and the capacity will be doubled as well. Before doing that, you can see it already came with a BMS circuit. But this circuit is not powerful enough for this project, so it needs to go. I am using some heat-resistant tape to hold these batteries together. After connecting these batteries, a bigger BMS can be attached to protect the batteries from overcharging and discharging. After that, it can be connected to the circuit. What about charging these batteries? As the batteries needs around 14 volts to charge properly, we can't use a regular charger anymore. That's where this module comes in. It is designed specifically to charge 3S batteries. It takes regular Type-C input and posts that input to appropriate voltage to charge the batteries. Now it can be connected directly to the battery. Now it's time for the enclosure, and PVC sheets would be great for this. Making these sheets is also extremely easy. Just take a PVC pipe and cut it lengthwise. After that, some heat can be applied to soften the pipe, and then keep it placed between two flat surfaces until it cools down. That's it. After cutting them to the appropriate measurements, some superglue can be used to keep them in place. And don't forget to make some necessary holes before putting everything in. Once everything is in place, I'm using some glue to secure them properly. And after that, everything can be sealed inside the enclosure. Now 2 pieces of hollow plastic can be attached to create some distance for the high voltage endings. And 2 sharp-ended wires can be used to create the plasma arc. I am using heat shrink to isolate the wire, just exposing the sharp ends. And some adhesive should keep them in place. And finally, the build can be finished with some sanding. After the sanding, it looks very clean and aesthetic. Now let's have some fun with it. Look at the steel, it just melted into a tiny ball. What about the paper? It's just instant. And a pencil. Didn't survive either. So that's all for this video. Don't forget to like if you enjoyed, and I'll see you next time.